The problem is from GATE 2017 mathematics paper, question number 30. The problem given is, let real part of Z and imaginary part of Z denoted by RE of Z and imaginary IM of Z respectively. Denote the real part and imaginary part of a complex number Z. Let E from C union singleton set infinity to the same set be the linear transformation such that T of 6 equal to be the bilinear transformation such that T of 6 equal to 0, comma T of 3 minus 3i equal to I and 3 of 0 equal to infinity. Then the image of the set D is the set Z belongs to C such that modulus of Z minus 3 is less than 3. Under the mapping W equal to T of Z is, the four given options are: option A, W belongs to C such that imaginary part of W is less than 0. Option B, W in C such that real part of W less than 0. Option C, W in C such that imaginary part of W greater than 0. Option D, W in C such that real part of W greater than 0. The NPTEL reference to solve this problem is lecture 26 of lecture 26 with title Binary Transformations of the topic Advanced Engineering Mathematics by Professor P. N. Agarwal. He is from Department of Mathematics, IIT Roorkee. Even you can watch this reference video using this YouTube link. So now coming to the solution. To solve this problem, first of all, we should know the definition of the bilinear transformation. So bilinear transformation is nothing but a function of the form Az plus B divided by Cz plus D with the condition AD minus BC is non-zero is called a bilinear transformation. Where Z in C minus the singleton set minus D divided by C. But since here it is given that CE in the domain and codomain are nothing but extended complex plane. Here the point minus D divided by C also included. Since infinity is included, the function this bilinear transformation is defined even at this point. Since usually at this point minus D divided by C, we get the value of this expression as infinity. So we omit this point. But this problem, since it is included infinity, so we can take this point inside the domain. So given that T of 6 equal to 0, comma T of 3 minus 3i equal to 3 minus 3i is I and T of 0 is infinity, comma T of 0 is infinity. So now from these three conditions, we have to formulate the bilinear transformation, and from then when we formulate that bilinear transformation from this given set, we can find the image of this set under the linear transformation. So firstly, for this we have to calculate the bilinear transformation. By just looking at these three conditions, we could observe two things. That it is given T of 0 is infinity. That means 0 is a pole of this bilinear transformation. And the first condition, T of 6 is equal to 0. That means 6 is a root of this bilinear transformation. That means, but from this definition of bilinear transformation, we can observe that since T of 0 is infinity, that means in the denominator, when we keep the value of 0 as z, the value of z as 0, we are getting infinity. That means in the denominator, there are nothing, the values of C and D are nothing but D is 0 and C is either 1 or minus 1. So that implies we have T of Z equal to, in the denominator we get D as 0 and C is plus or minus 1 and Z. So in total I am grading plus or minus Z. So when we write like this denominator, we can get the value of T of 0 is infinity. But coming to the numerator, since it is given 6 is the 0 of this bilinear transformation. So we get this as either z minus 6 or 6 minus z. That means plus or minus z minus 6. That is in total we get plus or minus z minus 6 divided by z. This is nothing but our linear transformation. But out of this plus or minus, which one is our bilinear transformation? For that, we have to use this second condition. Even by substituting the values, even by substituting the domain values and codomain values, one can easily calculate the values of A, B, C, D, but that is a lengthy process. Since from these simple conditions, we can easily formulate the values of the bilinear transformation. So I did in this way. But the question here is whether it is plus z minus 6 divided by z or minus z minus 6 divided by z. So for that, I'm using the second condition. Suppose t of z is z minus 6 divided by z. Then we have t of 3 minus 3i is I. So we have to check whether this is satisfying or not. That is, since we have assumed z minus 6 divided by z and z is 3 minus 3i, so I'm just substituting in this expression. Sorry, z is 3 minus 3i. So whether we are getting this value as I or not. If it is I, then we can easily see this is our bilinear transformation. So for this, I'm just substituting this as this is minus 3 minus 3i divided by 3 minus 3i. So this is in total we get minus of 1 plus I divided by 1 plus, sorry, 1 minus I. So for is this value equal to I or not? So for that, I'm just doing the rationalization. Then we get this as minus 1 square minus I square, sorry, plus I square plus 2i divided by 1 square here also 1 plus I. So we get 1 square minus I square. So that is t minus 3i minus 6 divided by 3 minus 3i is minus 2i divided by 1 minus 1 I square is nothing but minus 1. So we get this as 1. So this is nothing but minus I. But since it is given t of z is t of 3 minus 3i is I. So, but since we assumed t of z is z minus 6 divided by z, so in that case we are getting that is t of 3 minus 3i is minus I. So t of z is not equal to z minus 6 divided by z. So we get t of z is nothing but 6 minus z divided by z. So this is our bilinear transformation. But it is not what it is asked. It is asked that the image of this circle under this map. So for this, we have to look at this some circle. So given D is Z in C, such that modulus of Z minus 3 is less than C, 3. So this circle is nothing but when we assume this is 3, so we get the circle as approximately this circle. Modulus of Z minus 3 is less than 3. So, so now to check the image of this circle under this bilinear transformation, T of Z equal to 6 minus Z divided by Z. So we assume this as W, and here we can follow in two ways. That from the given options, one can check by taking some particular points in this domain, and we can check the image of the resulting complex number under this map. But one can even try in this map in this way, that by taking this bilinear transformation as z and calculating the value of z in terms of w, and since it is given in terms of z the condition, so when we finally substitute, we get the value of w in terms of some real part or imaginary part. But since that is a lengthy process, I'm trying the method that I'm just taking some points in this domain d, and I'm checking whether we can eliminate any option or not. So since it is our d, so I'm considering the point 1. So we can easily see that the points inside this circle are nothing but all the complex numbers, and in particular we have the complex number 1, 2, 3, 4, 5. So I'm considering just the value of the complex number 1 under this map, as we get 6 minus 1 divided by 1, that is nothing but 5. So let's see whether we can discard any option from this condition or not. So we can easily see that when we consider t of 1 equal, we are getting t of 1 equal to 5. So from this, and 1 is belongs to d. So from we can see 5 is the image of 1 under this map d. So we see, can we check whether some options can be discarded or not? Since 5 is purely real number, so we can see these two options, option A and C, are discarded. Yes, since 5 is real number, so imaginary part of this 5 is 0. So we can see these two options are discarded. And coming to the options B and C, we can easily see that since 5 is greater than 0, so that is nothing but real part of W is greater than 0. So we can see option B is obviously discarded. So option D is the only correct answer.